Hello everyone, my name is Pratik Prajapati. This video is regarding the brief presentation of mid-semester exam of the Human Robot Interaction course. The title of this particular paper is Multiple Input, Multiple Output System Identification for Characterization of the Limb Stiffness Dynamics. And the authors to this paper are Eric, Robert and Anna Maria. So let me first start with the motivation of the particular work. So as you can see here, the human is doing pulling activity and we can see that he recruited biceps, triceps and other muscle for this activity. Hence in most of the such activities, number of muscles are involved. And a stiffness of a joint's limb play a fundamental role while doing a specific activity. Thus, identifying how the stiffness of each muscle varies provides a unique perspective of how nervous system controls the postures and movement. And using stabilizing property of stiffness could be useful in restoring movements in the disabled individuals by rehabilitation interventions such as a reconstructive surgery, external orthosis, and functional neuromuscular stimulations. Moreover, a one single joint study would not enough to understand all fundamental features of the real movement, because you can see here that for a particular activity in the most of time, multiple muscles are recruited. Hence, the motivation of this particular study is to identify the multi-joint endpoint stiffness property using multi-input, multi-output system identification techniques. So in brief, we can say that by actuation of particular one muscle, it affects the overall movement of the particular hand or leg. Let me first start with the methodology. So this work represents two types of approaches. So one is a frequency domain identification and other is a time domain identification. Frequency domain identification provides a transfer function of each of the single input single output subsystem, and while time domain identification provides the estimation of subsystems impulse response functions. So if we consider any general particular system having n number of inputs and m number of outputs, so they are affected with the, so as you can see here that the first input is affected with this first output, also it affects the mth output. So likewise, this is the overall structure of how particular number of inputs or multiple inputs affect the multiple outputs. So in the first frequency domain analysis, the authors have considered this sort of a transfer function. So HYX means the how my first input affects the ith output. Accordingly, they have identified this coherence measure to relate how each inputs are related to each other. So gamma square x1 x2 is equal to 0 means that there is no any dependence between the two inputs x1 and x2, and if the value of gamma square is in between 0 and 1, that means they are somehow related, the x1 and x2, these two inputs are somehow related to each other, and gamma square 1 means that both are linearly dependent, that means both are the one and the same thing. In the time domain analysis, they have calculated the impulse response function. So this is a general form that they have considered, and again this phi xi by j means that what is the relation between input and output. So ith input and the jth output, what is the relation between them, and again these are the relation between the two inputs xi and xk, and h represent the impulse response function. So in this particular paper, they have considered the simulation for a two joint dynamical system, and so they have considered this sort of input spectra which is used in all the simulation. So as you can see here, this in the y-axis they are applying the forces per unit frequency, and at each frequency how much force they are applying, which is indicated using this particular graph. So the simulation is carried out in the MATLAB Simulink, and they have considered two models. One is a linear model and the non-linear model. So these are the result of the frequency domain analysis. So dynamic compliance means that what is the relation between the impulse imposed force and the resulting displacement. So if we consider this for graph, then and they have there is a theoretical value and there is a estimated value they have calculated using this model, using this frequency domain analysis. So as you can see that in each case, in H11 transfer function, H12, and each transfer function, they are almost coincide with their particular estimated values. And similarly, you can see here that their particular coherence also exactly matching with their estimated ones. So from this particular frequency domain analysis, they conclude that the nonlinear centripetal Coriolis coupling moments and nonlinear joint to endpoint transformation appears to have a little effect on the overall system linearity during small amplitude stochastic endpoint perturbations. And considering the time domain analysis, so they have considered this sort of uh, simple planar hand movement in planar hand movement, and they have analyzed the system performance in the four position. So these are the particular theta s and theta e configuration of upper arm and lower arm, and they have calculated this sort of R2 and VF measure, and from then they have identified that this particular transfer function and the percentage error or the accuracy is also almost the same as the estimated one. And this particular result shows that the estimated impulse response functions predicted more than 99% of the variance in the simulation impulse response function. So that indicate that the non-linearity were the insignificant. So in the conclusion, they proposed two sort of methodology to characterizing the multi-input, multi-output dynamic stiffness properties, non-parametric, and independent perturbations were imposed more than one direction, so which result in the covering entire stiffness field. And the presented algorithm can fully capture both the static and dynamic properties of the perturbation response without assuming a particular model, and the algorithm is very robust against significant output noise and coupling between noise, and the effect of nonlinear inertial properties and nonlinear joint to endpoint transformation were shown to be negligible for a small stochastic perturbations.